right, when we think of an antiderivative, basically what we're saying is we've already found the derivative of something, and now we're going to find what the original function was. So we're looking at what we began with. So if you think about that, like let's just think about one thing. So e to the x plus 2. What would its derivative be? Well, its derivative would be e to the x, and the 2 would go to 0. So the derivative loses the constant. This would be why the general form is always plus c, because there is an arbitrary constant somewhere on this function. The derivative graph only tells us the slopes, but it doesn't tell us where we started or what the actual x and y values are of the function. So that'll be the most common mistake that people will make. They'll forget to have that arbitrary c tacked on to their antiderivative, or to their antiderivative. So we have the derivative, we're going backwards. We're finding the antiderivative. So we'll go through this. We have a table of antiderivatives that we're going to talk about. But first, why don't we just kind of guess? What do we think? So I'm saying to you that the derivative of some function is sine x. What would the original function have been? Well, we know it had to be the form cosine. So we know it had to be the form cosine x plus c. But the question is, if I take the derivative of f, if I find f prime, wouldn't that be a negative sine x plus 0? So in actuality, in order to get this to be a positive sign, we need to have a negative right there. So therefore, the antiderivative, or the original function, must have been negative cosine x plus c. That would get us a derivative of sine x. All right, likewise, on this guy here, I know that when I take the derivative, the exponent came down. So the original exponent must have been 4. So I must have had x to the 4th, and I brought that 4 down. So I brought the 4 down and then made it 3. So, and if we test that, wouldn't the derivative of x to the 4th be 4x cubed? Now, anybody notice what I forgot to do? When I find this antiderivative, I need to tack on my plus c, because there might have been a plus 5 on that, or plus 7 on that. If you look at the notes that I've given you, there's an entire table full of the antiderivatives, the basic antiderivatives. You'll see on there that the antiderivative of a sine is negative cosine. The antiderivative of cosine is sine. So all of those different derivatives will be on there, and antiderivatives will be on there. So I'm going to ask you to pause the tape and go ahead and look through those for a minute, kind of study them, and hopefully they make sense. Then when you're ready, go ahead and start the tape again, and we'll go on to some examples. Table of antiderivatives. All right, it also might be helpful for you to keep out that table of antiderivatives that you found in the notes, because some of these are going to be way easier to do if you know that. All right, so I am telling you this is f prime. So we need to find f. So in other words, we need to find the antiderivative. Well, we know the antiderivative of e to the x is just e to the x. So that one's easy. But now the antiderivative of 4 over 1 plus x squared, that looks a little more complicated. So I would maybe pause the video right now and look at the table of antiderivatives and see if you see something that resembles that. All right, hopefully you noticed that arc tangent would have 1 over 1 plus x squared for its antiderivative, or I guess the antiderivative of 1 over 1 plus x squared is going to be arc tangent. So since there's a 4 out front, that just becomes the coefficient to our arc tangent x. And then we cannot forget to tack on our plus c. Now, we would be done if we didn't know any more information, but we have been given that f of 0 equals negative 2. So in other words, we can plug in 0 for the x's. So we can plug in 0 for the x's, so e to the 0 plus 4 arc tangent of 0 plus c, and we know that that should equal negative 2. And now I have this equation here that I can solve. So I know that arc tangent of 0 is 0, and if you're not sure, plug that into your calculator. So we have negative 2 equals 1 plus 4 times 0. plus c. Or negative 2 equals 1 plus c. So negative 3 equals c. If negative 3 equals c, our final antiderivative would be f of x equal to e to the x plus arctangent x minus 3. And this time we don't have a plus c because we could actually solve and find the plus c. All right, in our next example, we're actually given the second derivative. So we're going to have to apply this process twice. So we're given the second derivative. So I'm going to find the first derivative first. So if I do the antiderivative here and I follow my derivative rules for this function says add 1 to the exponent, so that'll be to the third, and then divide by that new exponent. For the next one, it's 6x to the first, but then add 1 and divide by that number. And the next one we know had to have just been 4x, and we have plus c. All right, with that done, we can go ahead and simplify that down a little bit. We have 4x cubed, and you can go ahead and verify that if I did the derivative, I would get 12x squared, plus 3x squared, and again, you can verify that that would get you 6x squared, minus 4x plus c. Now, on your notes, this is an f prime here. On my notes, I was missing that prime. So we know a point on the f prime graph, which will help us solve for c. So we're just going to simply plug that in. So f prime of 0 should equal 4. So in other words, if I plug zeros into this, I'm going to get my c. And conveniently, every single one of these goes to 0, so c equals 4. So f prime of x equals 4x cubed plus 3x squared minus 4x plus 4. So that's f prime. But we're supposed to find we're supposed to find f, not f prime. So we need to apply this process again. Right, so I have 4x, now we add 1 to the fourth over that new exponent. 3x, add 1 to the exponent over that exponent. Add 1 to the exponent, divide by that new exponent. Add an x to the 4, and I'm going to say plus d this time because I've already used c. So f of x will equal, if I simplify this, x to the fourth plus x cubed minus 2x squared plus 4x plus d. All right, now I have enough information to solve because we were given in the original that f of 1 will equal 1. So I'm going to go ahead and say 1 equals and plug in a 1 for each of the x's. All right, and when I'm done with that and I simplify everything down, I end up getting d equal to negative 3. So, if d is equal to negative 3, our final answer would be f of x equals our x to the fourth plus x cubed minus 2x squared plus 4x minus 3. Now, if you wanted to verify, you could go ahead and do the first derivative and then the second derivative and make sure that you get the same thing that we got in the beginning. All right, so our last example is going to deal with acceleration. And we need to get back to the initial displacement or the position function. Well, we know that acceleration is the second derivative. So this is going to be very similar to the problem we just did. We know that if we take velocity's derivative, we get acceleration. Well, since we have acceleration, if we take its antiderivative, we will get the velocity. So I'm going to go ahead and take this acceleration function, and I'm going to apply my process where I add 1 to the exponent and divide by the new exponent. And add the x onto this one, but it's going to be a t this time because the velocity is in terms of t, plus c. All right, and then I was told that the velocity at 0 seconds is negative 6 centimeters per second. First, though, I want to simplify down, or I want to simplify the velocity. So I get 3t squared plus 4t plus c. And I know that I can put that -6 in here and plug in zeros for my t's. And conveniently, these both go to 0, so I have -6 equals c. Therefore, my velocity function's equation is 3t squared plus 4t plus, well, we probably would rather have -6. Right, but we didn't need to find the velocity. We need to find the acceleration. So we're going to go ahead and find acceleration, we need to find the position. So we know position is the antiderivative of velocity. So if I apply my rule again, I'll have 3t cubed over 3 plus 4t squared over 2 minus 6t plus d. All right, let's simplify that. Position function would be t cubed plus 2t squared minus 6t plus d. And now we need to solve for d. Well, we were told that when at the starting point at time equals 0, the position starts at 9 centimeters. So in other words, my position is 9 when my time is 0. And again, conveniently, these all go to 0. So we have d equals 9. So my final antiderivative or position function is going to be t cubed plus 2t squared minus 6t plus 9. And again, you could go ahead and find the first derivative, verify your velocity, find the second derivative, and verify your acceleration. And then you can feel pretty good that you got back there okay. All right, good luck on your homework. Come see me if you need help.